Hi students, welcome back to my YouTube channel. This is Neeraj Bansal. Today we have, in the last video we have worked on the basics of complex numbers. Now we'll move further with the same topic. So let's say today we are going to do complex, right? So now the most important thing in complex numbers is, I just tell you, representation on Argand plane. Representation on Argand plane. I'll tell you what is an Argand plane. In the last video, we have said that a plus bi or a minus bi is the general form of a complex number. This is also called the rectangular form or Cartesian form. We can represent every complex number on a Argand plane. Argand plane is nothing but just like an x and y axis. So this is x axis and this is y axis. X axis is called real axis. Y axis is called imaginary. Got it? Perfect. Now, if I have a number, let's say 2 plus 3i. So what I'll do is, this is my real axis. So I'll run 2, 1, 2 and rise 3. So my complex number is here. This is my complex number 2 plus 3i. If I have minus 2 minus 3i, then how will I represent negative 2, negative 3? So it will be somewhere here. So I hope this is clear to you how to represent a complex number on Argand plane. Then we can do addition, subtraction, multiplication and division, and then represent the number on the Argand plane. When we'll do the questions, you will understand. But first we are doing the concept of whatever is required for this lecture, and then we'll do some questions on it, right? So let's say I can represent it in another form. So basically, let's say this is my complex number. Let's call it 2 plus 3i only. This length, this is the length, let's call it r. R means magnitude of this or the length of this line. This is my x, which is 2, and this is my y, which is 3. Now I can represent this complex number in the form, like this point can be written as, if I take x, so basically this complex number is x plus yi, right? So let's call this x. So let's call this angle theta. So cosine theta is equal to adjacent over hypotenuse. So x is equal to r cos theta. And similarly, I can write sine theta is equal to y over r. Or I can say y is equal to r sine. So in place of this x plus yi, I can write r cos theta plus r sine theta I. Or I can write it as r cos theta plus I sine theta. This form of complex number is called polar form or modulus argument form. Here we always, this r is called magnitude of complex number. and theta is called argument of z, or commonly arg z. Basically, what happens when we are talking about arg z, it is always taken from the positive x-axis. So if this is my angle, this will become my arg z. And when it is here in the third or the fourth quadrant, we don't take it from here, we take it like this. Got it? So the domain for arc z, theta is greater than equal to 0 and less than equal to pi, and theta is greater than equal to negative pi and less, sorry, and less than equal to 0. Clear? So now when the angle is here, I'll take the negative angle, and if the angle is in the first and second quadrant, I'll take the positive angle. When we'll do some questions, you will understand it better. Perfect. So this is what it is all about. See, this r times cos theta plus I sine theta. In short, we call this cos theta and I sine theta as cis theta. This and this means the same thing. And some important things to consider is r cannot be negative. Got it? I hope this is clear to you. Yes. Then when we'll come to the addition, subtraction, multiplication, division, and then so this is the thing. So r cis theta x plus yi. We have learned two forms of complex numbers. R plus yi is equal to rectangular form, of complex number, or we can also call it Cartesian form, right? And then we have another form which is r cis theta, or r cos theta plus I sine theta. This is called modulus argument form, or polar form. Now we'll talk about the properties of cis theta. Let's say we have two complex numbers. Uh, let's call it z cis theta and w cis phi. W and z is the magnitude of the complex numbers. So if I want to multiply these two numbers, so it will be z times w times cis of theta plus phi. That means magnitudes will be multiplied, arguments are added. Yeah. Then we can also divide these two numbers. So if I divide z cis theta over w cis phi, then it becomes z over w cis of theta minus phi. Clear? That means magnitudes are divided and arguments are subtract. Now we'll start doing the questions, so it will become much better for you. You will try to understand, you will understand these concepts better. So let's go for the first question. Perfect. Let's paste. Yes. So suppose z1 is equal to 4 plus I and z2 is equal to minus 1 plus 2I. Find using both algebra and vectors. We already know from vectors topic. I have made the video. You can go to my channel and then you can see those videos on vectors. Two vectors can be added, like if this is vector A and if this is vector B, and you want to add the two vectors, you have to go like this: vector A, vector B. You have to put the head of on the other, and then this will give you the magnitude. This will be vector A plus vector. The complex number is also like a vector only, right? So let's make this. What I'm doing is 4 plus I and z2 is equal to minus 1 plus 2I. So what I'm going to do is, let's take 4 plus I. First I'll take z. 1, 2, 3, 4. 4 plus I. So this is my z1, complex number. Now when I'm making vector this, I'll start from here because I want to keep the this will be my origin because I want to keep my vector here. So negative 1 and then 2I. So my this number will be something like this, right? So this is my thing. So this is z1, this is z2. So I'll call it z1 plus z2, right? By the triangle law of vector addition. So this is how you will add them. And if you want to add it simply, that's fine, because then in that case 4 plus I plus 2I minus 1. So this will give me p plus pi. Yeah. So if you do it, you will get the same answer. So z1 plus z2 we have done. Z1 minus 2z2. So again, it will be something like this. My z1 is same here, somewhere here. And minus 2z2, that means negative of twice of z2. So let's call this negative 2z2 addition. Answer. Got it? Then 2z1 and conjugate of z2. So conjugate is making the same angle, right? So 2z1 will be something like this, twice the length. And then let's say this is my, I want to keep thing here. So my z2 is somewhere here. So conjugate is, which is same but making an opposite angle, somewhere here it will come. So this will give me the answer, right? Or I'll make it a little nicer. We'll understand it better. Let's take it that. First I'll make 2z, right? 2z1. And then z2 was something like this. So the negative of z2 will be like this. Sorry, conjugate. So I'll keep this vector here. Let's take it. And this will be my answer. So this is 2z1 plus z conjugate. We have already done in the last lecture. Conjugate is when you sub a plus bi, the conjugate of a plus bi is a minus b. This is done. Very good. I hope this is clear. Let's move to the next question. Yes. So let's say z is equal to 2 plus 3i and w is equal to minus 3 plus I. Find zw. This is very simple. So z is equal to 2 plus 3i, w is equal to negative 3 negative I, multiplying the 2 plus 3i times minus 3 minus I, which will give me 2 minus 2 and minus 3 minus 6 minus 2i minus 9i and minus 3i squared. So this will become minus 6 and plus 3 because negative I square. Okay. So plus 3, so negative 3, negative 11i. Got it? If you want to represent it, represent all the three in the Argand diagram, again it is very simple. So first we'll represent z is equal to 2 plus 3i. So 2 plus 3i, this is my z. Then minus 3 minus I, 1, 2, 3 I. So minus 3 minus I, which is w. And the number is negative 3, negative 11i. 1, 2, 3. So negative 3 and negative 11. Let's put it somewhere here. This is negative 3, comma, negative, negative 3, not comma, negative 3, negative 11. Hope this is perfect, right? Let's move to the next question. So whenever you are asked of modulus and argument, it is always best to first plot the diagram. First represent it on the Argand diagram, then you will not make mistake. So let's do part A. 1 plus 3i. So 1 and 3i, it will go somewhere here. So this is the theta, that means argument of z. This is 3, this is 1. So my theta is equal to tan inverse p, right? And my magnitude is under root of 1 squared plus 3 squared, which is under root of 1 plus 9, which is under root of 10. So this is how we will find it. Same way if I have minus 1 and 3i, let's do minus 1 and 3i. So this will lie somewhere here. Now this angle will be tan inverse p, right? And I have to subtract it from the pi to get this. So my this angle will be pi minus tan inverse p. So this means my arg of z, that means arg z is equal to pi minus tan inverse 3. And my modulus will be same, which I got earlier. Clear? Now let's do the third part. Then you will understand. Minus 3 minus I. So negative 3, negative I. Right? So basically what I want to do is I want to find this angle. That will be my argument. So this angle is, let's say, tan inverse 3. Got it? So this angle will be negative pi plus 10 negative 3. So this will be 10 negative 3 minus pi. This is my arc z. I hope this is clear to all. Perfect. Let's move to the next question. Of course, if you find any doubt, even after seeing the thing, then you can contact me on the numbers given below, right? So let's do the fourth question. This you have to do like, let's say they are saying this is modulus of z, this is regarding the magnitude. So if you have got a question like this, 3z plus 1 is equal to z, this we have already done in modulus functions, right? How to solve these kind of problems. So find magnitude of z given that this. So first of all, we need to understand one thing. Magnitude of z cannot be negative, right? Mod cannot be negative. So what I can do for finding this? Squaring both the sides, right? So when I'm squaring both the sides, it will be 3 squared times z plus 1 whole squared is equal to z plus 9 whole squared, right? So this will give me 9 times z square plus 1 plus 2z. Sorry if my z and 2 looks the same. Is equal to z squared plus 9 square, which is 9 9s are 81 plus 18z, right? This becomes 9z squared plus 9 plus 18z is equal to z squared plus 81 plus 18z. 18z cancels. So 8z squared is equal to 81 minus 9, which is 72. Right? So sorry. Just give me a quick moment. Yes. So this is 72. So z squared is equal to 72 over 8, 9. It implies z is equal to plus minus 3. But since magnitude of z cannot be negative, therefore magnitude of z is equal. You have to, in IB, you need to understand one thing. When you get two solution and one is rejected, you have to write, I am rejecting this solution because of this. Perfect. So we are done with this question as well. Let's move to the next question. So basically, this question is a very simple question. Like we have already done in coordinate geometry, the distance formula and the distance formula and the midpoint formula. Let's start this question. So P can be written as Z is equal to 2 plus 3i, and Q can be written as W is equal to 6 plus I. So if you want to find the midpoint, first we find the distance. So distance will be given by magnitude of Z minus W, which is, so we can do magnitude of 2 plus 3i minus 6 minus I, which will give me 2 minus 6 is minus 4 plus 2i. So if I want to find the magnitude, that is under root of 4 squared plus 2 squared, which is under root of 16 plus 4, which is under root of 20. Perfect. We have got this. Then when we are talking about the midpoint, midpoint is Z plus W over 2. So this will be 2 plus 3i plus 6 plus I over 2. So this will give me 8 plus 4i over 2. So which will give me 4 plus 2y. So that is the midpoint. That means my this point is 4 comma 2. Perfect, right? Let's move to the next question. So let's move to this question. Let me enlarge it. Let's do this question. Right. So write it in polar form. Polar form means you have to write it in the form of r cis theta. That is the polar form, right? So I'll just do it. That will be r cis theta. So if I plot this, this will be like 2i will be somewhere here on the imaginary axis. So this is my number. So my magnitude of this is 2. So magnitude, let's call it z is equal to 2i. So magnitude of z is equal to 2 and arc z is equal to this angle, which is pi by 2. So arc z is equal to pi by 2. So my answer in this form will be 2 cis pi by 2. Done. Then let's make the second one. In this case, it is saying z is equal to -3. So if I plot it here, this distance is -3. So this angle I have to find. So this angle is pi. So magnitude of z is equal to 3 and argument of z is equal to pi. So this is 3 cis pi. Perfect, right? Let's move to the next question. Now I want to convert this into the Cartesian form. Let's do it. So first I'll write it in a very simple form. Then I'll able to. So I can write it like root of 3 cos 5 pi by 6 plus I sine 5 pi by 6. So 5 pi by 6 is pi minus pi by 6. That means it will lie in some second quadrant. So pi minus theta is pi by 6, right? So this will be, and pi by 6 cos pi by 6, that means 30 degree. Root 3 cos pi by 6, cos is negative in the second quadrant, right? So cos negative cos pi by 6 is equal to negative root 30 degrees. So this is 30 degrees. So this will be like, I'll take it negative of root 3 by 2 and sine pi by 6, that means sine of, okay, I'll do it little better so that you understand it better. Just give me a moment. I'll write it as cos of pi minus pi by 6 is equal to minus cos pi by 6, which is negative root 3 by 2, and sine of pi minus pi by 6 is equal to sine pi by 6, because in second quadrant sine is positive and cos is negative, will be half, right? So my answer will become root 3 times cos pi by 6 negative root 3 by 2 plus I times half I, right? Then you can solve it. So this becomes minus 3 by 2, root 3 times root 3 plus root 3 by 2 I. So this is my final answer. Clear? Let's move to the next question. Perfect. This is easy. So I want to solve this. So use the properties of cis to simplify cis pi by 5 and cis 3 pi by 10. So when we are multiplying, it's like multiplying two numbers, cis of pi by 5 times cis of 3 pi by 10. So we have already done that the magnitudes will be multiplied 1 times 1 and the arguments are added, pi by 5 plus 3 pi by 10. So this will give me cis of 2 pi plus so this will give me 2 pi plus 3 pi by 10, which will give me cis of 5 pi by 10, which will give me pi by 2. So my answer is cis pi by 2. Clear? Right. Let's move to the next one. So cis of, again this is simple, cis of pi by 5 divides cis of 7 pi by 10. So this will give me cis of pi by 5 minus 7 pi by 10. Got it? Which will give me cis of 10 2 pi minus 7 pi. So which will give me cis of negative pi by. Hope whatever we have done today you have understood. Please see the video 1 or 2 times, and obviously yes, if you find any doubt you can contact me on the numbers given at the bottom, and in the next video we'll further continue with the complex numbers. So you can I have made different plays in my channel, so you can go to that particular playlist. If you are an AHL student, go to AHL concepts. You will find my videos and you will find it better to find different kinds of videos or find videos on different topics easily, right? So please subscribe my channel.